Well, Hannah already gave me quite a good introduction, so I'll just move on to a little bit about me. So I've just completed my master's doing water and environmental management at Queen Mary, and I've always been interested in macroinvertebrates since my undergraduate degree. And I know some of you haven't done any river fly stuff before, but I personally love going out into the field and usually with my friends or fellow students and going out and actually being able to look at all these fantastic invertebrates that are in the river that beforehand I didn't actually know were even there until I started studying this. So I also think it's really engaging as well, and it's a really great way to bring scientists in and volunteers and collect this data because, like I said, it's actually really enjoyable and really fun. And that led me to investigate the accuracy and effectiveness of using citizen science biomonitoring methods to determine phosphate pollution in the River Chess. So that was for my research project for my dissertation. So just a little bit more as to why I chose to study this. So Smart Rivers data from 2023 suggested that there was one particular site, Broadwater Bridge, that had consistently lower scores than the rest of the downstream sites. And they also suggested that there might have been an issue with phosphate. And this was particularly unexpected as well because Broadwater Bridge is located upstream of the sewage treatment works in Chesham. So you wouldn't really expect there necessarily to be a phosphate issue. You would expect that to be more downstream. So I really wanted to look into why and what was causing these low scores. And you can see in the table there where it says Broadwater Bridge, the scores are, and these are just macroinvertebrate scores, are much lower compared to the Little Chess and Trout Rise, which are the downstream sites. So I really wanted to try and investigate why this was and if we can use Smart Rivers and extended river fly to try and figure out if phosphate is an issue at this site and what could be, if it's not, what could be causing that. And one of the main objectives of my investigation was to compare Smart Rivers and extended river fly to see what the difference was in the data, and what it tells us. So a little bit going more into the actual difference between Smart Rivers and extended river fly. So a kick sample with Smart Rivers, a kick sample and a stone search, as Steve had talked about earlier, is carried out by citizen scientists. However, that sample is then taken to a lab and then experts then ID it down to species level. And then you get some macroinvertebrate scores, which just tells you, the number of taxa, species richness, abundance, things like that. And then you also get biometric scores that are specific to certain types of pollutants. So for example, you have total reactive phosphate, organic pollutants, silt, flow, and sphere, which is more specific to pesticides and insecticides. And then with extended river fly, it's more kind of all done by citizen scientists. So, you go out and take the kick sample, and then citizen scientists do the bankside identification, and then once they've got the numbers, they can go and put this onto cartographer and then get the scores straight away. And I guess it's important to note that extended river fly is considerably cheaper than Smart Rivers because it's all done by volunteers. And also I think it's more engaging as well because the citizen scientists are part of the whole process, and they actually get to go and look at the macroinvertebrates as well. So these were my scores from 2024. And as you can see again, Broadwater Bridge has consistently worse macroinvertebrate scores, still don't know why, and that's also reflected, I think, in the water quality score as well for the extended river fly for Broadwater Bridge. However, when you look at the biometric scores for Smart Rivers, total reactive phosphate doesn't seem to be an issue at all. And if you look at all the other metrics as well, nothing really seemed to be pointing out as to why these scores were still so low. So I took my own measurements of phosphate and nitrate, ammonia, and some other water quality metrics as well. So temperature, dissolved oxygen, carbonate content, and nothing stood out as to why the macroinvertebrate scores were still consistently low at Broadwater Bridge, which kind of leads on to a point that maybe it wasn't necessarily to do with the water quality, and it could have been something to do with, well, in this example, what we think it could be is to do with distance from the headwaters. So Broadwater Bridge is the most upstream site, And as you move downstream, it's likely that channel heterogeneity will increase as the channel gets wider. It's probably more riffle and pool patches and things like that. So it's important to kind of consider when you do get your water quality score from extended riverfly, if it's not obvious that there might be a pollution issue, you know, you're not near a sewage outfall, it's important to just also consider other factors that could be influencing the score that aren't necessarily water quality related. Okay, and I wanted to have a closer look at the actual difference between my Smart Rivers data and the extended riverfly data. So obviously Smart Rivers goes down to species level, so I've simplified this into family level, so it's just a little bit more comparable. And as you can see, this was at Broadwater Bridge, and as you can see just by looking at it, Smart Rivers were able to pick up a lot more invertebrates that were missed in the extended riverfly sample. So what I actually, and then this is a table showing at all 3 sites all the species that were missed in the extended riverfly sample but were picked up in the Smart Rivers sample. And obviously there might have been some where like they just weren't in the extended riverfly sample. Obviously that happens because each sample is slightly different. However, that's probably not the case for every single one. So what I did just to have a look at what the scores would have been, I put the Smart Rivers macroinvertebrate raw data into Cartographer to see what the extended riverfly scores would have been if I'd used that data. And as you can see, this is for Broadwater Bridge, the water quality score increased by 10, the silt and flow score increased by 8, and for some reason the ARMI score actually decreased by 1, and I'm not 100% sure as to why that is. Maybe Steve will know, I'm not 100% sure. But as you can see, just by looking at it, we really want to try and close this gap and try and make extended riverfly as accurate as possible so that our scores are, as accurate as they can possibly be, and then they will help inform us with restoration and management. So, some potential errors that I think that I might have made during my extended riverfly. The first thing is misidentifications. So these are 3 mayflies that are in the extended riverfly. So there's the olive, the angler's curse, and the blue-winged olive. And I was going to say under a microscope, they're much easier to identify, but even looking at them now blown up, it's still quite difficult, especially if you're a beginner, to tell the difference between them. So when you're in the field and maybe it's a rainy day and you're in a bit of a rush as well, it's quite easy to sort of just guess, or it's very easy to mix them up basically and get confused. And I think that looking at my counts between extended riverfly and Smart Rivers, I think that might have happened quite a few times, especially angler's curse. I find that one really difficult in particular. So that's the first, I think, a really easy error that people can make even after you've been trained. Another thing is, and I only learnt this later on in when I was doing more extended riverfly surveys, but it's quite easy to count empty casings. So when you're counting the one, what you've got in your tray, you need to make sure not to include the caddisflies, particularly the weighted case maker. I find they hide in their casings and they don't come out for a while. And it's difficult to tell if there's actually anything in there or not. So it's important to wait and see if they eventually poke their head out, because I think I might have overcounted them a few times, possibly. So yeah, that's another mistake that's quite easy to make. And then also, just obviously with Smart Rivers, they go right down, they spend ages going through the sample, and it takes a few weeks to process, whereas extended riverfly you do in a couple hours, and it's really easy to miss certain species that, yes, have a really small abundance, but also might be really small in size as well. So beetle larvae, crane fly, alderflies, bivalves, and limpets and things like that are really easy, especially if there's only a couple of them. They can be quite easily missed in a sample. So I really wanted to try and think of ways and just little improvements that we can do to close that gap between the 2 numbers, and try and make extended riverfly as accurate as we possibly can. So just some little recommendations that I thought of that might be really useful for extended riverfly. The first thing is, along with the big sheet with the 33 identification taxa, I think something that would be really useful would be another A5 field booklet, which would have larger images of particular species, such as the mayflies, larger images and diagrams, highlighting their defining features and how to spot these differences, including species that you might get confused with and might be misidentified for, and to kind of highlight those differences so that you can make sure you can tell them apart. And also, just like how there were the videos on YouTube, to also have descriptions and diagrams on how they move. And I know that's in the that's on the sheet as well, but to have that as well next to, like, in a bit more detail, I think would be really useful. And then another thing, I think working in small groups is really important, especially if you're a beginner or if you're not as confident and you haven't been doing it for that long. Because if you just have more eyes in the tray, people are more likely to spot things that you might not have spotted. And also people can point out mistakes that you might have made, and errors that you might not have realized otherwise. I also think it's good that beginners and people who are just starting out should be accompanied by more experienced citizen scientists, because personally I learn best when I'm in the field and when I'm doing the surveys, and people can point out to me when I'm actually out doing it, things that I might be getting wrong, or little tricks to remember certain species and things like that. And also just small things like taking pictures of taxa that you're unsure what they are and take them home and show other people instead of just guessing. Make sure you're sorting your trays properly and make sure you're not getting lots of macrophytes or reeds in your sample, because that can also make it difficult to find species that have a low abundance. And then lastly, something like extra training days with the opportunity to look at macroinvertebrates under a microscope. That personally really helped me, because once I was able to see them under a microscope, I could see their defining features. And then when I went back out into the field, it was so much easier to say, like, oh yeah, that's an angler's curse. However, I understand that that's not necessarily affordable and cost effective, which is why something like an A5 booklet could be a really good alternative, just as like a supplementary resource to help limit the amount of errors and mistakes that could occur. Yeah, thank you so much.
Thank you.